Hello again. So continuing on this contest, 167, I'm going to try to solve this problem. So the second one, which is sequential digits. So an integer has sequential digits if and only if each digit in the number is one more than the previous digits, right? So sequential basically. We want to return a sorted list of all integers in the range, a sorted list of all integers in this range, inclusive that have sequential digits. So 100 to 300. So range 123 to 223 really, because let's see, what are these? Okay, so let's see what are these. So they are like this. So let's call them range, right? And they just do a list. Okay, so you can see each digit in the number is one more than the previous digit. One more. I guess this is not. These are just the two values, right? In this range, 100 to 300. Okay, I see. I think the problem is that if you take this range to 300, the only numbers that are sequential digits in it are these low to high. Are these two here? 1, 2, 3, and 2, 3, 4. In this range, it's these numbers. So how can we? Well, there is an easy solution, which is just generating all of them, and then trying each one of them, seeing if it's a sequential digit, which can be done by just converting it to a string and then going through each element. But that is probably too expensive because it can be from 10 to 10 to the power of 9. And that would be, yeah, so I think that would be too expensive. Well, one thing we can do is just generate, is there a way to generate all sequential? Okay, let me try some examples here. So okay, so let's try that solution there. So the first thing we need is probably something for sequential digits at position I, and we need to check if it's a solution. So and then we need the number that we have so far. I'm not sure if it's going to be a string or not. And so if n is less than or equal to low, less than or equal to high, then we can add it, right? To what actually? So we can add it probably to res equal to this, and we can have n starts out as, I guess, 0, and then well, no need to do that here. We could just say the helper here, so let's call this one helper, and our helper can start out at 0, 0, and at the end we can return res. Now if it's a solution, we're going to say append n, and so only if it's in there, and then here the numbers that we need to explore should have some property, which is what could it be? So we know that we have that digit, so maybe I'm sure about this one. So first I need maybe to say SL just to get the string for low and high, and sh, and this one for high, and then I could say for v in range of course, if it's 0, then it's going to be different. So say upper and then lower bound and then upper bound, right? So our upper bound, if like SL is I is equal to 0, here also if we are done, we need to move out, right? So so 0 here, that's what I wanted to check. So here I want to check if I is more than the length possible. Actually, we could just say if n is bigger than high, then we should stop, right? So just return, right? There is no need to continue. And here we could also try that there. Here we should say if so for the first one, lower bound, I guess if it's this, then we should say, then we should try 1, right? Else we could just say int of SLI, right? The value at that position is the lower bound. And then for upper bound, well, we could say 1. Actually, if it's 0, then it's 9. Really? Yeah. I'm talking about the last number. And this is for sh. Otherwise, it's h of I. And here we could just go from lower bound to upper bound and start exploring. And so the way we could do that is that for whatever number in that range, right, we can check if, well, if I is bigger than 0, then if it's equal to 0, then we don't need to. But if it's bigger than 0, then, so it's actually not 9. Yeah, 9 if it's 0, right? Now, if I is bigger than 0, that means we should say otherwise, if it's equal to 0, what should I do? So if it's equal to 0, we don't need to check, I think. You can just generate any number in between, right? And go with it, which means we should say helper is n, which is the first number, so it's just v, whatever number we picked, and I becomes I plus 1, right? For this one here, it's going to be helper of so it's going to be the number so far. We are going to multiply by 10, right? Because we are adding a new one, and then plus v, and then after that we are going to go to I plus 1. And yeah. But one thing that I didn't do is only if the last digit, which is like a star of n, right? Like this, if we take the last one and convert it to an int, only if v is actually equal to that plus 1. Then we, so it's sequential, right? Then we can explore and do the helper, otherwise we shouldn't, we should skip it. Okay, so let's see. Yeah, you'd be upper bound. It's empty because never added. Okay, let me take this into here and then just go code. Okay, and take this so we can debug it easier. And then we need to take this one, which is just taking solution, and we can have this one with 1 and 300. Just print that. So list is not defined. List. Oh yeah, I called sequential. So what list is not defined? So list the result. Okay, yeah. This definition. Okay. Okay, so something is wrong. We go here, and then helper goes there. So right now lower bound is 1, upper bound is 3, which is good. So we go explore v equal to 1, right? And to I plus 1. And so here low is 100, so it's not in between there, so we don't do anything. And I is 1, so lower bound here it's going to be 1. Lower bound is actually 0 because the value is 0. What? So SLI is 0, right? But it didn't work. So what is the valid expression here? So SLI is actually not equal to 0 because SLI is 0. Oh, I see. It's a string. That's why. So we need to have character string check here, and same thing here. String index out of range. Okay, so we don't exit when I, so we get then length of sh. I'm not sure about this one. Okay, so that looks like it's correct for that number. Now let's try 1000. Okay, let's try something simpler. Let's try 2 and 4. 3, 4, 5. It's correct. Okay, let's try 100 too. Okay, let's try 600 here. Okay, that seems good. Now let's try 1000 to 13,000. 1000. Okay, that one didn't work at all. Okay, So it seems like when the number of digits is different, it doesn't work. So lower bound started as 1, upper bound as 1. Yeah, it should have been 13, right? Yeah, I think we need to do something with the first lower bound and upper bound, right? So if I equal to 0, I need to do something, else I can do this. Okay. So if I equal to 0, then I need to take the difference. So d, which is the difference between the length of both of this one minus the length of, which would be potentially 1 for the second one, right? So I need to add. So the first lower bound is going to be the same. It's actually the second one that is going to change. So the upper bound is going to be different. So upper bound is going to be so it's going to be sh of basically I, so b basically plus 1, right? Because it's going to be, let's say 1, we want to go up until 2, so that if I have, let's say, sh is equal to 30,000 and I do sh for 2, it's going to be 13. That's what I'm looking for. And it's going to need to be an int, right? And that's pretty much it. So that's where we get 1, 2, 3, 4, 2, 3, 4, 5, 1, 0, 1, 2. This one is wrong. This one is absolutely wrong, which means 10 here. Yeah. So this digit has to be so here the problem is the first digit, right? So the problem here is the first v there. So I need to check if so here is only if v. So okay. It's becoming complicated. So only if length of sv is equal to 1, or if it's a sequential one, which means sv of 0 is not very good, I think. So that's the string, right? So length, we want to compare every two numbers, so I'm going to do -1. So if si, right, if vi, call it s maybe, so make sure it's, so if si is different than, so sequential, so si plus 1 is different than this one plus 1, then it's not sequential, it returns false. Otherwise we can return true. And this yeah, so this needs to be an int. conversion. 1, 2, 3, 4, 5. So it's kind of messed it up. Yeah. Okay, I think this is not good, especially the portion where I'm doing this lower bound, upper bound. I think doesn't look good, great. Okay, this guy's probably just has them, all of them. Okay, let's just see how many does this solution solve correctly, just to get an idea of where it fails. Probably will fail very early on, but yeah, it failed on the input, so which is actually the first test case. Okay, so I think this is starting to be like too much. So I think it could probably be made easier. So I'm just going to try to do it without doing this, and just doing a brute force thing. So I know that I have a list, and I know that I need. Let's just generate numbers. So I know that I would need a digit that goes from 1 to 10, right? And I know that I have I need two numbers, right? I need the first number and then the one after that. So the first number I'm just going to call x. I'm going to give that a digit, or let's call it number, right? And then I know the next number needs to be let's call it x. The next number needs to be something also that is after it, right? And then or maybe like this, and then I know that the next number is going to be in the range of okay, let me just, the next number, let's call it y here, and then while that value x is less than or equal to high, right? We don't want to surpass that, it's not necessary, and we don't need that number if it's bigger than high. And what else? And then I know that I need the next number, which is the next number y, to be less than 10, right? If we reach 9, we don't want to go beyond that, right? Because yeah, you can't put 10, it's digits, and then I want to construct the number that I'm going to try to add, which is pretty much going to be so what I can do is check if x, this value x, is less is bigger or equal to low, so it can be included, so I'm going to add it to the result. And then I want to check if I want to construct the next iteration where y needs to be +1, because what we are doing is sequential stuff, right? And then x is going to be basically x multiplied by 10 plus y, right? The value y, which is going to be here for the digits multiplied by 10, so that we can get, for example, 23 if digit was 2. And so 2, and then 2 plus 1 is 3. That's what we are having by using y here. And then after that, I could return. I'm not sure if it's res or I need to sort it, but this is the while loop, and I need to exit if I have more than high, so I will exit with this while loop. And I guess that's pretty much it. So let's see if this is actually good or not. So the test case here is good. Let's see with other test cases, like the difficult one that I had here. Let's put this one here. Okay, so yeah, this is not, I need another 0 here. So if I look at this, on these examples, it does look correct, yeah. So this one is here, but this one is here, so they are not sorted, so I guess I will need to sort them, because the problem description says that they need to be sorted. Okay, let's submit. Okay, so that passes. Okay, so this is a lot easier than doing that recursive thing, which was a little bit complicated. Okay, so that's it for this problem. Thanks for watching, and see you next time. Bye.